is 3.4, solving rational equations and radical equations. So the first example that we're going to do is we have x minus 8 is the example they have in the book, over 3 plus x minus 3 over 2 equals 0. We're going to do something called clearing the denominators. So we're going to multiply both sides by whatever the least common denominator of the fractions would be on each side. So on this particular side, the least common denominator is 6. I can get that by just doing 2 times 3. And what I'm going to then do is take 6 times each thing. So I'll have 6 times x minus 8 over 3 plus 6 times x minus 3 over 2. I'm going to simplify as much as I can. So 3 goes into 2, or into 6 2 times. 2 goes into 6 3 times. And then I will have 2x minus 8 plus 3x minus 3. Most of the time, you guys can probably skip writing out this line, and you could just do 2x minus 16 plus 3x minus 9. I'm going to combine my like terms. So I will have 5x minus 25 equals 0. I'm going to add 25 to both sides. I have 5x equals 25, and x will equal 5 after I divide by 5. Okay, so that's how you can solve a rational equation with numbers underneath my full numbers in my denominator and no variables. So that's a rational equation. Then we are also going to do some ones that are harder that have a variable in the bottom. Okay, so these ones are actually also pretty nice. I have x squared over x minus 3 equals 9 over x minus 3. Okay, anytime I have anything over the same square root, or not square root, I'm sorry, over the same denominator, I can basically almost ignore the denominator, and I'll kind of show you how this works. But basically I still want to see these steps. I need to get x minus 3 out of the bottom, so I'm going to multiply both sides by x minus 3. And just so we realize that it's a fraction, I'm going to do it over 1 so that I don't accidentally kind of multiply in the wrong place. And I have to do everything I do on both sides. Okay, what's going to happen here is my x minus 3's will multiply to 1, so I have basically 1's everywhere. And here I will just have x squared equals 9. I square root that. You guys know how to solve from here. I have x equals the positive and negative square root of 9, which is 3. Okay, so those ones are pretty nice to solve. Anytime I have a variable in the bottom, I also need to go back and check my answers. Whenever I check my answers, I have to plug them into the original equation. So for negative 3, x equals negative 3. Oh, I can't write anything. X equals negative 3. And then we'll also do it for x equals positive 3. So we're going to come back up to the original equation. I will have negative 3 squared over negative 3 minus 3 equals 9 over negative 3 minus 3. Okay, negative 3 squared will be positive 9 over negative 6. On this side, I'll have positive 9 because I already had that. Negative 3 minus 3 is negative 6. Is 9 over 6 the same thing as 9 over 6? Yes, that works. This is a solution. Negative 3 is a solution. Now I'm going to plug in positive 3 into my equation. I will have 3 squared over 3 minus 3 equals 9 over 3 minus 3. 3 squared will be 9 over 0. The other side will still be 9 over 0. We cannot divide by 0. It's just not defined, so this is not a solution. So I'm going to write x does not equal 3. So that's probably one of the harder parts, is to actually go back and check your answers. But everything that we're going to do in this section, we have to, because some answers just don't work. So this this problem actually only has one solution. So x does not equal positive 3. Okay, the next example that we'll do has 2 over 3x plus 6 plus 1 over x squared minus 4 equals 4 over x minus 2. So what you're going to want to do, basically all our variables are on the bottom, and that's fine. But what we're going to have to do is factor things as down as much as possible. So my numerators will stay the same. So I still have 2. A 3 can come out of both 3x and 6, so I have a 2 out front over x plus 2, or a 3 out front, not a 2 out front, I'm sorry. So times x plus 2 plus 1, x squared minus 4 factors down. It's a difference of squares. So I'll have x minus 2, the square root of x, square root of 4, times x plus 2. And that will be equal to 4 over x minus 2. Okay, and remember how we just did it when we had numbers in the denominator? We cleared the fractions. So the first thing that we have to do is decide what our common denominator is. So, I didn't mean to do that. I'm going to pick a different color to write that out. So I have an x minus 2. I have that in 2 places. So my least common denominator will definitely have an x minus 2 in it. I will also have an x plus 2, because I need that x plus 2. I have a couple different things that have that x plus 2. And this term over here actually has a 3 in it as well. So remember, even just a couple seconds ago, we found our least common denominators by basically multiplying these two numbers. So that's what we can do even when we get into variables and when we have other things on the bottom. So we'll multiply both sides by 3 times x minus 2, x plus 2. Does not matter at all what order they're in. Okay, I'm going to go ahead and write them. We'll go ahead and write them, but I'll tell you, you can skip some things. So I have this 3 out front times this 2, or I will write out these things. I have x minus 2, x plus 2, parentheses times 2, all over 3x plus 2, plus 1. So I will have 3 times x minus 2 times x plus 2. Since that's all times 1 from this guy, I'll write the 1. It's not going to change anything. And that will be over x minus 2, x plus 2. And that will be equal to 4 times 3 times x minus 2, x plus 2 over x minus 2. I like to write these in parentheses even though I didn't do it up here. And I like to do that just so that I can make sure that I realize that it's multiplication of stuff. So when I multiply, or these ones will divide out to 1. I also have some x minus 2's over here that will multiply to 1, or divide to 1. Over here, my x plus 2's will multiply to 1, and my 3's will do the same as well. Okay, so on this side here, I will just have 2 times x minus 2 plus 3 equals, then I will have 12 times, I'm going to actually go ahead and write it still out as 4 times 3 times x plus 2. And that way you can just really see what happens. I'm going to write this times 1 since I had a 1 on the numerator. What happened here was the numerator just got multiplied by what it didn't have in the bottom. So what piece of my common denominator does this thing not have? Okay, so basically I just had to multiply the numerator by what was missing from the bottom. So if you guys can kind of understand um, getting from this step here, this in blue, to this step down in purple, without doing this step, I'm okay with that. If you're having problems, I'm going to make you write out this whole thing though. So just we're multiplying by what our common denominator has to be. Okay, and then I can go ahead and actually multiply things out from here. So I will have 2x minus 4 plus 3 equals 12x plus 24. I'm going to get all my numbers and all my letters on the same side after I add my like terms. Okay, so I'm going to add 1, add 1. I'm going to subtract 12x at the same time. And I will have negative 10x equals positive 25. I'm going to divide by negative 10. Divide by negative 10. And x will equal negative 2.5. And remember that I have to go back and I have to plug stuff back into my calculator. I have to actually check those answers. So when I check those answers, I'm going to leave this here. I'm going to do all my work up here so that I don't have to scroll down. I'll have 3 times 2.5 plus 6 plus 1 times 2.5 squared minus 4. Is that equal to 4 over 2.5 minus 2? And this should all work out. We can get everything down into decimals. So I'm just going to plug this in the calculator. Okay, for this first piece, I got 0.1481. And then for the other piece, I'll have 1 over 2.5 squared plus or minus 4 in parentheses. And I get 0.444. I'll go out 4 decimal places, so hopefully you were just able to hear me since I didn't have my microphone down. On the right hand side, I'll have 4 divided by 2.5 minus 2, and that will equal 8 over here. Okay, so I accidentally forgot my negative sign here. So on all my 2.5, so I have negative 2.5. So this piece, whoops, is actually negative 1.33. So this is negative 1.3333, lots of 3's, plus 0.444. And with this negative sign here, I actually get negative 0.88. And when I add these together, since they're continuous and they go on forever, or they're irrational and they go on forever, I actually do get negative 0.8. If I were to have done this with fractions when I checked it, I would get the same thing. When we have things that go on forever, though, you can round to check your answers. Hope this works out. So I would say negative 2.5 is a solution. Again, hopefully you already noticed, and I'm just testing you really. Okay, now we're going to solve some equations with square roots. First ones are really simple. So I have the square root of 3x plus 1 equals 4. Okay, anytime I had any sort of equation, I always want the square root, the thing with the square root, on the side by itself. And then I'm going to square everything. So then I'll have 3x plus 1 equals 16. All that happens when I square something with a square root is I'm left with what's underneath, which is just the 3x plus 1. Okay, on this side, since it's just 4, I just have 16 is 4 squared. And then I'm going to solve this just like I normally would. I'll have 3x equals 15, divide by 3, and I will have x equals 5. Okay, so that's a really easy one. I always need to go back and check my answers. So, and when I'm checking these answers, I really don't go from side to side. I forgot to tell you that with the rational ones. I need to basically keep everything on the same side that it was on before. So I'll have 3 times 5 plus 1. Is that equal to 4? Okay, this is my original equation that I plugged it into, always into your original equation. I'm going to take the square root. 3 times 5 is 15 plus 1 equals 4. And then I'll have the square root of 16. Is that equal to 4 still? 4 is equal to 4. Good, my answer checks, so x equals 5 is a solution. Okay, anytime I can also use my calculator, so I'll show you how to do that in a couple seconds. Let's do one that's going to be a little bit harder first, though, because some of these do get very confusing and just weird to work with. So they have the equation 5 plus the square root of x plus 7. That equals x. Okay, I have to get stuff with the square root by itself first. So I'm going to subtract 5. I'll be left with the square root of x plus 7 equals x minus 5. Now I have to square this. A lot of times what you guys want to do, even now, even though you know better, is to just say x squared minus 25. That's my answer. That's not right. That's not your answer. On the left side, I do have x plus 7. On the right-hand side, I have to FOIL that. I'm not going to do that. I'll do it. Okay, so I have x minus 5 times x minus 5. I will have x squared minus 5x minus 5x. That's not working. Plus 25. And so when I add my like terms, I have x squared minus 10x plus 25. Okay, I get all my x's and all my numbers all on the same side. Don't try to get them on different sides now that I have an x squared. So I'll subtract 7 from both of them, and I will subtract x at the same time. So then I will have 0 equals x squared minus 11x plus 18. Okay, so I'm going to try to find factors of 18 that will add to negative 11. So I have 18 and negative 11. My factors of 18 will be 9 and 2. They will both have to be negative in order to get to negative 11. Okay. Since I don't have anything out front, this factors nicely just x minus 9 and x minus 2. I said them separately from what I actually said. And so that will mean that x will equal positive 2 and x will equal positive 9. Okay, again, I have to go back and check my answers. So back to my original equation for my 2. I have 5 plus the square root of 2 plus 7 equals 2. And I'm going to check this out. I have 5 plus the square root of 9. Is that equal to 2? The square root of 9 is 3. Is 5 plus 3 equal to 2? No, the 2 is not a solution. Now I'm going to plug in 9 and test out this. So I have 5 plus the square root of 9 plus 7. Is that equal to 9? So I have 5 plus the square root of 16. Is that equal to 9? 5 plus 4 for the square root of 16. Is that equal to 9? Oh my gosh, I think it might work. You guys should be happy that this works at this point. So kind of maybe try to distinguish between your answers. Put a slash through stuff that doesn't work, circle things that do work. That'll be really easy for me to go through and look at. Now, the way that we're going to do stuff is also another way to kind of look at this graph or to solve these things. So I'm going to clear my key press stuff. I'm going to go into my y equals menu. What I'm going to do is I'm going to have 2 separate equations, basically the stuff that's on each side of my equal sign. So on my left-hand side, I will have 5 plus my square root sign And your guys' might look a little bit different. It's okay if it does. And I'm going to have x plus 7. And for my next equation, I just have whatever is on the other side of my equal sign. And I will just have x here. I'm going to look at my graph. Let's look at the large screen of my graph. Okay, so this crosses right here. I wish I could just like take a picture. Okay, so when I look at my solutions, it crosses here. This would be at 9. This is my x value of 9. So x would equal 9 for both of these values. They would also have the same y value if you wanted to plug this in and find their y value, which you could look at it and it looks like it might also be very close to 9. Um, so that's another way that you can solve these if you have calculators. So that's good. Okay, so we have one more example that I want to do. And it is, some of these examples will be long, or some of these problems will be long. And that happens when I have two things that have square roots and I don't have the same thing underneath my square root. If I have the same thing underneath my square root, I can combine like terms just like I had just a plain old x, and maybe I'll look at an example of that when we get done. Okay, here I just have to make a judgment call. Which one do I want to work with? Which one do I want to get alone first? It does not matter which one. In this case, I'm just going to subtract the square root of x minus 5, x plus 5, keep the same sign, minus the square root of x plus 5. So now on this left-hand side, I have something in a square root all by itself, so I can square it and get rid of the square root. However, on the left or on the right-hand side, I have something that is not going to work out nearly as nice. Okay, so when I square that side, it'll come out nice. However, when I square this right-hand side, I am actually going to have to FOIL this out. So what I'm going to do is I'm just going to write 4 minus the square root of x minus 5. We're going to do that. And maybe actually part of this example will actually show you what I mean by combining like terms. So on this left-hand side, that's my nice easy side. My first term over here, I'm going to go ahead and write it in a different place so that I can simplify it and write it right here. So this side alone equals 16. This is not going to be enough room, I'm not thinking. So I have 4 times 4 is 16. I have 4 times the negative square root of x minus 5 will be negative 4 square root of x minus 5. Okay, my inner terms will be this negative x plus 5 times this 4. So I have another negative 4 times x minus 5. X times 5 times x, the square root of x minus 5 times the square root of x minus 5 is going to just be equal to plus x minus 5. So what's underneath that square root when I times that by each other? So when I go back to write it underneath, and write it on my next line, and you guys can work down if you want to. I just don't like taking up all the room. When I make fun of you guys for not wanting to do the same thing. I get 8 right here because I have 2 negative 4s. So I can combine these things together just like I would if this were just a plain old x. So I'm still just counting how many square roots of x minus 5 I have. Plus x minus 5 at the end. Okay, I'm going to get all my x's and all my other numbers on the other side by itself. I want to get the square root alone by itself. Okay, so I'm going to go ahead and do that. I'm going to subtract x. So that x will actually add to 0. So on this left-hand side, I'll have negative 3. I'm going to combine my like terms over here. So I have a 16 and a negative 5 that have like terms. So I'll have 11 minus 8 over, or times the square root of x over minus 5. Okay, I am now going to get the square root by itself, so I'm going to subtract 11 from both sides. So now I will have negative 14 equals negative 8. Oh, and I keep messing up. Did I mess up the whole problem? Just a second. Okay, I messed up some signs here. The original problem had an x plus 5 underneath the square root. So I'm going to go back and just fix some of those things real fast. So then when I actually do that, this will be an x plus 5. And I will get a 21 right here. So I'm going to subtract 21 instead of 11. Okay, negative 3 minus 21 is negative 24. Yep, so definitely pay attention to your signs and be able to go back and find your sign mistakes too. That's part of being good at math, is that you can also find your own mistakes. Okay, so now I'm going to divide by negative 8. So I have to have this just completely alone when I square that. Okay, 24 divided by 8 will be 3 equals the square root of x minus 5. Now it's nice and easy to solve. I have 3 squared is 9. That squared is going to just be x minus 5. I am going to then add 5. And, oh my gosh, I keep doing this. I've made this mistake I don't know how many times. It was a positive 5, so now I have to subtract 5. And I am sorry about all that mistakes, all those sign errors. So now when I subtract 5, 9 minus 5 is 4. That equals x. I'm not done yet because I always still have to check my answers. So when I go back and I check my answers, back to my very, very original equation, I'm going to kind of do that, try to separate that a little bit. I will have the square root of 4 minus 3 plus the square root of 4 plus 5 equals 4. Okay, so this was actually my original equation, and then I had done other stuff to get this negative square root of x plus 5. If I could probably say it right, I probably could do it just fine. 4 minus 3 is 1, so the square root of 1 is just going to be 1. Not an equal sign yet. Square root of 9 equals 4. Square root of 1 is 1. Square root of 9 is 3. That equals 4. So I have 4 equals 4. And 4 is an answer. And it is just a total coincidence that actual x equals 4. And that I had 4's over here. So your homework, I want you guys to do stuff on page 278. I want you to do numbers 3 through 96 by 3s. And number 96 actually looks like a little fun, so that's why I gave it to you. And I also just want you to remember, just so you know how to write it, if I get any answers where none of my answers were to check out, so if we want to look at some of the things where, like this number, not this number, the one before it, where this one worked and this one didn't. If I had 2 things that didn't work, I could just write like no solution. So, and you will have that quite a bit, more than you probably think you will. Not tons, but you definitely have some of them. And actually, I might be just lying to you because it doesn't look like the multiples of 3 have a whole lot of that happening. But don't be worried if you get stuff that happens like that. So there you go. I'll see you in class tomorrow.